Good afternoon. Thanks for joining this session. My name is Billy Field, and I'm here to talk to you a little bit about OpenStack backup and recovery, and what Trilio is and what Trilio does. So for the next few minutes, I'm going to hit on a couple points here. Quick intro of myself, quick little 5-second background, who Trilio is, and what we are into OpenStack, what we do, and what we provide our end customers. The common tools and complexities that point tools and legacy-based protection modules provide. And on inversely, what OpenStack data protection, what are the needs, right? I'll talk a little bit about our solution and our architecture, where to find us, and then lastly, I'm going to do a live demo. So none of that canned stuff recording. So getting right into it. So I run all pre and post sales at Trilio. So I oversee everything from POCs. I talk to all our customers, all our prospects, and I walk them through the whole process, getting into the post sales perspective, okay? My background is EMC and Actifio, and solely focused on data protection and storage. And if there's one thing I want you to take away from this session today is what we are and what we do best, okay? So we are the only native OpenStack backup and recovery platform on the market. And there's 3 things we do really well. We protect, we recover, and we can migrate OpenStack workloads, okay? We have patents, we have a lot of customers, industry recognition, awards, but I think you take away from this session what we are, we're OpenStack native backup and recovery, okay? So if you are on the journey to the cloud, whether you're doing investigation work, if you've got stuff in lab, if you've got OpenStack in production, a lot of the common challenges around data protection are handled in this way, right? Whether it's a series of scripting, cron jobs, take things like array-based snapshots, you can do host-based tools, host-based replication, host-based software, legacy point tools, media servers, disk targets, et cetera, et cetera. You got database tools, application tools, and the good old NDMP or NFS-like dumps, okay? So as you can see, there's a lot of different tools, right? And these are point tools. And the challenge here is none of these are built with OpenStack or cloud in mind, right? So all these, if you deploy them, you're going to have multiple of them. And what it's going to drag into your infrastructure is going to drag into a lot of complexity, right? So you have to manage a lot of backup sets. So whether you're managing Excel sheets and scripts, and then you got to take account of the VMware, the VM flavors, or the images through glance, the network configurations, the volume mappings, and then lastly, security groups, firewall settings, et cetera, okay? So if you backtrack into the legacy point tool set, into this model within cloud, it becomes very, very complex and very, very tedious. So the legacy approach is not cloud, end of story, okay? And what that means is the legacy point tool solution, plus what I just told you about with the complexities, has a direct impact of data protection within OpenStack, right? It impedes SLA violations. You can't guarantee RPO, RTOs for your customers and for your tenants. The complexity of which I just talked about having a lot of heads to manage a lot of different tools. Those tools incur costs, so TCO of these solutions become, these building blocks of renewals and other tools. You become a risk module more than a protection solution. But the big thing that I'm seeing in all the protection, in all the customers and prospects that I'm talking to is it's hindering the cloud deployment. They can't move and port production workloads over to the cloud because they can't sustainably protect those workloads. And then lastly, on top of that, then their application and development team cannot build the dollar, which is the business, which is the data. So those applications are getting delayed. So on the flip side, so what should data protection in the cloud look like? All these points: agentless, agnostic, scalable, right? OpenStack, you can start with a 5-node config, you can scale up into the 100 nodes. You got to be able to scale elastically with that cloud, right? So should your backup solution and data protection solution. It's got to have DevOps integration, right? Because you deploy these clouds, every distribution has their distribution engine that they can, Ansible or you name it. So that's where Trilio comes into the picture. So all those cloud attributes is what we've built into our product, okay? So we are agentless, so we are zero impact to your cloud. No restarts, no reboots, no shutdown of any OpenStack service. You deploy us seamlessly, and you're off to the races. We adhere to multi-tenancy. In fact, we are tenant-driven. So the tenants with our solution can go ahead into their cloud and provide their own backup and recoverability in a self-service manner. We scale. So we're just an add-on module, and I'll show you a little bit of the architecture here in the next slide, but we're just an add-on module within the compute stack, and as that scales linearly, so does Trilio. We're non-disruptive, okay? We seamlessly provide integrations into DevOps tools, such as Ansible, Chef, Puppet, and the last thing here is we are OpenStack integrated. So we have a plugin through Horizon, we have a full REST API and CLI, and as you can see in the picture to the right, we are just an add-on service within the OpenStack framework. Okay? And what do we capture? So workloads mean a lot of different things to different people, but a workload is the entire VM layer down to Cinder storage, and that inclusive of the VM image, the networking, the availability, the security groups, the storage configurations, the volume types, et cetera, et cetera. Trilio captures the cloud at that point in time and backs that up. In addition to that, what we do is we protect the data. So we'll talk native APIs to Nova, Cinder, Neutron, you name it, to get all the components I just spoke about. But the last thing is we then back the data up. So we leverage Cinder-based snapshots per VM to associate, to grab only the unique blocks that have changed from those workloads, and then copy that over to the repository. From a repository perspective, we can write to any NFS-based target and or Swift-based object store. At the end of this year, we're going to have S3 integration, so you'll be able to port backup images to Amazon, to any S3 compatible type media. So at a high level, what this is showing you is that we integrate and piggyback on all the OpenStack native services. We don't add any other complexities. A Trilio-like service that gets deployed out in its heavyweight operation, we integrate and piggyback off the native APIs. At the very bottom are the distributions that we qualify, including upstream. So you can see those 4 vendors. And then to the right are our target repositories, with the bottom 2 being by the end of this year. So backup is one thing, right? Well, what about recovery? So what we provide is tenant-level recovery in a self-service manner. And me as the tenant can go into my OpenStack environment, and I can go into my workloads, and I can go ahead and I can do what's called an in-place recovery. So if those VMs in the part of that workload are corrupt or got deleted or squashed, I can restore back into production. I also offer that tenant the ability to do availability or region recovery. So if I captured from availability zone number 1, I then can give the ability to the tenant to restore into availability zone number 2, which unlocks a little bit of a couple different use cases, such as test and development. You can start talking about agility. You can start talking about a couple different components, maybe some workload migration. Or you can recover to a whole cloud altogether. Because if you think about our approach, we're doing the metadata and the data into a target media. And as long as the target media is accessible between multiple different clouds, I can spin up that workload into a different cloud altogether. And last but not least, we provide the ability for the tenant to do file and folder level recovery. Okay, so even though I'm protecting the workloads as a VM, how I write the data to the target repository, I can do real-time file and folder level recovery for those tenants. A little bit about the architecture. What you'll see is this is a 3-controller OpenStack down to the compute layer through RabbitMQ. And then what you'll see is what we install is a lightweight Python-based data mover that goes on each one of the Nova compute nodes. Okay, so if there's 10 Nova compute nodes, you just put a lightweight Python component on each of those 10 compute nodes, and then you're off to the races. At the control plane, what we do, if you go to identity and access, we actually register an API endpoint because it acts like a router for us. Okay, so to the left is our TrilioVault VM. That's our distributed workload engine. It has our internal smarts of the scheduler for our tenants. It's a scale architecture, and it's basically the work engine of the Trilio solution. And then we leverage that hook into the registered API endpoint to get down to the OpenStack. Okay, so that's where we get our scalability. You don't need to put a TrilioVault VM into each tenant or into each compute node. We sit basically on the control plane, get in through the control plane down to the data mover, and then we back stuff up and recover. Okay. So these are just add-on services. It's Python. If you guys all know Python, you'll see what we're doing. It's all native, right? There's no secret sauce on the modules we're installing. If you're looking at logs, it's very readable, just like all the OpenStack logs, which is nice. So oftentimes say, okay, I get that, that's great. So, but tell me what you support. So what is your support today? So I qualify it into 3 buckets. Number 1 is our distributions. So we take all the distributions, and what we do is every single time OpenStack releases a release, I go to my distributions, I get the code embedded into them, and my QA and dev team go through and test everything, including upstream. Where do we start, and where are we right now on the version of OpenStack? We started at Kilo. We started before, but we officially support Kilo and beyond. We just finished up Okada, and we're working on Queens and Pike. And then last but not least, we provide application awareness. Okay. So even though we're doing VM level protection, VM level snapshots, point in time snapshots, we can leverage QEMU guest agent to invoke application freeze and thaws as needed. So if you have Oracle or MySQL or Postgres, we can go ahead and register that script to get application consistency. Okay? So where to find us? If you're here in person or if you're watching online, you're not going to matter for booth B22, but we're at B22. Go to info@trilio.io, or you can hit trilio.io, request a demo, and that directly gets routed to me and my team. It's a quick little questionnaire about your environment. You'll get a phone call or an email right away to set up an introductory call with our sales team and kind of go from there. All right, we got 8 minutes left, so live demo. All right, so let me log in here. So I'm going to log in as admin because it shows the whole stack here. But one thing you'll notice is underneath the projects tab, if I expand that down, Trilio, again, because we have a native Horizon plugin, we expose a new tab called Backups. Within Backups, for the tenant space, I have what I call workloads. And what a workload means to me is it is a logical grouping of my VMs that I've tied an RPO, RTO, frequency and retention policy. So if I want to capture, I have gold right here, I want to capture it every 4 hours and retain it for 30 days, that's what that workload will mandate. Same with silver. Silver I have as a 12-hour RPO, and lastly, bronze is a 24-hour RPO. Now creating a workload is very simple. All you do is click create a workload, and what we do is a real-time operation here. So we can give details about the workload. We do an active lookup on the actual VMs that are registered within my tenant space. So if you have Pepsi and Coke, and I'm logged into the tenant space as Pepsi, I can't see Coke's VMs, et cetera, et cetera. So I can go ahead and just select all these VMs, say that's my web job database server, you name it. And then what I can do is go ahead and tie my RPO, my schedule, and then lastly, how long I want to retain that data for. Now the nice part about this is we're empowering the tenant, right? So in a self-service manner, we're giving the tenant the ability to go ahead and define their workloads without reaching out to that backup team from the infrastructure side, okay? So the job scheduler is automatic based on what you define, so it automatically goes off without a hitch. You can add VMs, you can remove VMs, you can pick or choose however you want to do that. So if I dive into what a workload looks like, so let me go into Silver. And the beautiful part about our solution is, again, I want to echo this again, we don't just do file system backups. We don't do just volume backups. We get the entire stack, that workload from the tenant's point of view. If you took a virtual picture, a virtual snapshot, we get everything. From the floating IP of the VMs all the way down to the Cinder volume types and configurations, okay? And what this shows you, here is our metadata that we captured. So those are the VMs that are part of my workload. If I come over here to my policy, the Silver, if you remember, is a 12-hour RPO, which is what I've defined. We're keeping 30 points in time. And if I come over to the snapshots, what you'll see here is if I expand my page size here, Trilio does a full once incremental forever capture. So if I go to the very last base level 0, we do a level 0. So I take the cloud blueprint plus the data, copy the target. The next job is an incremental capture. So we use APIs to get what's changed. We use Cinder-based APIs to do snap differentials. So we can truly get only the unique blocks that have changed between T0 and T1, and forever incremental. So backup windows now shrink. Storage capacity now shrinks. A lot of good value to the incremental forever process. So if I dive into any point in time, I'll grab this instance, this snapshot, and what you'll see is those are the 3 VMs that I've put into the workload. And if you can see, hopefully it's not too small there, but I've got the IP addresses, what network that they're on. I have the metadata about the instances. I gather the security groups, the flavor, the network, and the volumes. And the reason why we do that is because backup's backup, but I want to flip it on them, and when I want to recover, these attributes are very, very crucial. If you picture just doing a volume backup and volume restore, if I don't have a VM with all these components, effectively it's useless unless I can get to that exact point in time, which is highly unlikely. So if I come back into the snapshots, the actual point in time, once I take a look at the metadata, here's a couple different operations that we provide for the tenant, okay? So from a recoverability standpoint, we provide a one-click restore, which is basically taking that point in time, writing it back to where it came from, with the same exact attributes, the same configurations, et cetera, et cetera. We offer a selective restore, which is slightly different. So the selective restore, I can go ahead and I can say, take that point in time, and what I can do is I can give it a restore name. I can go ahead and I can tie to a different network segment or a network altogether. So if I capture it on network 1, I can say restore into this, this region on this network number 2. I can go ahead and define the volume types. So if I have iSCSI or LVM in zone 1, or I have Ceph in zone 2, I can pick or choose those volume types. And then per VM, what I can do is a couple neat things. I can rename the VM. I can adjust the flavor, because if you think about recoverability, different regions might have different resources, compute, RAM, resources all together. So I can adjust the resources, and then what I can do is I can put the actual VM into a different region and the volumes into a different, different availability zones, disparate, zones if you want. So I can do that per VM, and I have the ability here to include or exclude altogether. So when I hit restore, it's going to take this template of which I've defined, and it's going to go ahead and do the restore operation. Okay. Another option I provide the tenant is to do an InPlace Restore. So maybe the VM's in good standing, and maybe dev 2 or dev B is messed up for some reason. I can pick or choose that specific volume, restore just that volume structure, and I'm off the races. So if I click on InPlace Restore, again, per VM, I can say, hey, restore the VM altogether, restore the VM including the boot disk, or I can multi-select boot disk and Cinder volume. So I can kind of pick and choose components I want to restore. Again, trying to give that tenant the flexibility to do their recoveries. And then the last thing here is maybe I don't even want to restore the VM or touch the VMs at all. Maybe what I want to do is I want to grab a file or folder, right? So we offer up a mount snapshot option, which basically takes the volumes associated with those workloads, and we ship a Ubuntu 14.04 file manager that sits in the tenant space. And what I'm doing is I'm just doing a logical mapping of the volumes tied to that virtual machine. I expose the volumes via web front or CLI, via SSHFS or CLI. The tenant can go in and CD and get whatever and copy everything out however they want. Okay? Or altogether, we expose a new real-time feature here called file search. So I can search the workload for a specific file or folder. Okay? So I can say search all my snapshots. So I'll take VM2. By default, we grab all the snapshots, but I can say, hey, grab the last 10 snapshots, 25 snapshots. I can filter based on our date range. Click apply, and by default, it goes with that criteria. So let's just say I want to search that snapshot for etc star and search. So what we're doing is, come by the booth and reach out to us, and I can talk a little bit more about how we're storing these, but we're writing the data in QCOW2 format, so it makes searching the image really, really easy for us. We're not writing it into Trilio proprietary format on disk somewhere or on object store somewhere, which means we don't need to retranslate it to give it back to the tenant. What I can do is I basically return via QCOW2 the file index based if I was doing an ls-la, like a long listing or a dir from a Windows perspective, okay? So from there, the user can go ahead and say, okay, I found the file that was there. I can go ahead and mount that snapshot and recover the file. The next release will actually have the recover and mount option right here for you guys to consume. Okay? And with that, I am 9 seconds over. That was perfectly timed. So again, thank you for your time today. Stop by B22. Reach out to us online. We have an admin layer that I can go into a little bit deeper to do advanced configurations of how to set up set everything up from ground up. We can go over how we deploy via Ansible or DevOps type tools, and just talk a little bit about everything in your cloud, how you got it deployed, and see if we can help work together. So thank you for your time, and enjoy the conference. Thank you.